Alright, now, remember what you've got for your assumption, right? Because that's what we're going to sub in here in a second. Our assumption was, I think you start with k plus 1, k plus 2, and then you go all the way up to 2k, right? That's on the left-hand side, and then this looks much the same, odd numbers in here. Dot, dot, dot. Does that look right? Am I in the right ballpark? Yeah, that's the assumption. So now, I'm up to step 3. I'm trying to actually prove this thing. When I go with the left-hand side, this is a little bit different to the previous ones, right? Because before, it's been nice and neat. You go like 1, 2, 3, 4, 5, up to k, right? And then you've got k plus 1 on the end. All you have to do is take the first terms. But you can't quite do that here, can you, right? Because the first terms here do not line up with these terms. Right? Can you see? My first term over here was k plus 1. My first term over here is not. Okay? So don't fall into the trap of just making a straight substitution even though this is not the right term. Okay? That's the kind of thing that we're looking for to see, have you fudged it or do you actually know what you're doing? You've got to do some looking around with this. Okay? Now, I should probably include, I broke my own rule, 2k is the last term that I need to sub in. Right? So I might put that here. 2k. Alright? So before I can get my substitution, I'm going to need to have a k plus 1 out the front here, right? I've got to get it in there somehow. Now you've sort of got two alternatives to get it there so that you can make your substitution. Number 1, I can just multiply by k plus 1. And of course we can't just multiply by things willy-nilly, right? If I've multiplied by something to preserve what I had before, I'd have to divide, right? So I could divide the whole thing by k plus 1, okay? Then I could substitute on the top and I could simplify from there, okay? However, there's probably a more direct way in this particular example, okay? So keep that in mind. Maybe you want to jot it down on the side, that multiplying and dividing is often a useful strategy if what you've got doesn't look like what you need to do the switch, okay? But here, where's my... There we go. Here, we actually have a k plus 1. It's just hiding. Where is it hiding? It's hiding here, right? Can you see? There's a k plus 1 in there. It's just not factorized, right? Yeah. So, what I'm going to do is I'm going to start to write out this line. K plus 2, k plus 3, and so on. All the way up to 2k. 2k plus 1. Instead of writing this last term, I'm going to write down 2 outside of k plus 1. Okay? And now I can bring this, is that right? Sorry, these are all multiplications, aren't they? My bad. No one picked that up. Maybe you're just being polite. I can now put that back where it belongs at the start of the product, and then I can do my substitution. Okay?
You have the x's. If they're next to each other, then there's still times. Alright. Sorry. Oh, you have to cut that out.
Okay, yeah, sure. I generally don't. The other day, the phone just fell out, and then we put it back. And I was going to edit it out, but I was like, no, let's just Anyway, okay, k plus 1 out the front, and then I've got the right thing. I can switch this out. Multiply it. Now, just watch now, because I've moved that over, the end of this series will look a little different. So, not series, product. That's the part I'll switch out. And then over here, just to make sure I don't confuse it, I'll have 2k plus 1 times 2. Okay, is that all right? So now, sorry, I've got here. The part that I'm switching out is here. All right? So now, by assumption, it's equal to this. Let's see here, 2 to the k outside of odd numbers. That times 2k plus 1 times 2. And hopefully you can see now, we're almost there. What's the target we're aiming at? This is what we want, okay? So the first thing you can see is this 2, where's it going to go? It's going to go with the other 2. That's where this k plus 1 comes from, okay? So that's good. This 2 will go all the way over there and become k plus 1. When you have a look at this thing, 1 by 3 by 5 by blah, 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 right? Remember, I drew your attention to the fact that this is not just any sequence of numbers, progression of numbers. They're the odd numbers, right? Now when you get 2k minus 1, 2k plus 1 is just the next odd number, right? Does that make sense? It goes up by 2, so it goes to the next one. And so what you've got is this, right? Can you see, actually, I was a bit sneaky. I wrote those down because I knew I'd need it for later, okay? So this part here is already equivalent. I just need to put this inside the big square brackets, and that's it. So 1, 3, 5, 2k minus 1, 2k plus 1. And that's it. That's the form I wanted to arrive at, okay? So that's equal to the right-hand side, and now you make your explanation by the principle of mathematical induction. Let's see here. What is it for? 1, 2, 3. Okay. So one of the cool things about induction is when you look at this, I know the first time I saw this, the program hasn't changed all that much since I went through. 10 years doesn't change that much in maths anyway. I looked at it and I balked. I was like, what do you do with that? It's just a mess, right? But if you follow through with your 4 steps, and what are we doing here? Just a bit of algebra, moving things around, factorizing. A year 8 could do this if you taught them the right steps, okay? If you just gave them this simplification, there's nothing dramatic there, okay?